Hello everyone, welcome to the ICMR ROD2021 challenge session. I'm the session chair Zhou from the University of Washington. This challenge is co-organized with Zhejiang University, Silkwood Holding Limited, and ATRI, South Korea. Before starting this session, I will first thank all the participants for your great effort and contributions to our challenge. I would also like to thank Professor Huang, Professor Wang, Professor Liu, Huang Zhu, and other IPL colleagues for co-organizing this challenge. So now I will first give a brief summary for our ROD 2021 challenge and announce the top 3 winning teams. Then I will give the time to the participants to introduce your methods for this challenge. Autonomous vehicles are usually a multi-sensor platform containing different kinds of sensors like camera, radar, LiDAR, ultrasound, and etc. Different sensors have different strengths and weaknesses. For example, cameras are usually good at for semantic information, but not reliable for depth estimation. Radar has great capability for distance and velocity estimation and robust to all weather conditions. However, it's usually oversensitive and has low angle resolution. As for LiDAR, it can collect dense 3D point clouds, but it is expensive and also not robust to the adverse weather scenarios. This makes LiDAR a kind of redundant when we already have the camera and radar on board. Ultrasound is usually very helpful for parking lot assistance. Among these sensors, radar is the one that has great potentials but significantly underdeveloped comparing with the camera and LiDAR. So therefore, in this challenge, we managed to accomplish an object detection task using the radar data. Typically, there are 2 different radar data representations. Radar points used in the nuisance dataset is an intuitive representation that shows the 3D locations of the reflected points. However, they are usually very sparse and can hardly describe the object semantic and or texture information. The second kind of representation is radio frequency image, which we are using in this challenge. It is frequency map in the range azimuth coordinate. RF images can obtain rich information, including object locations, shape, surface texture, and speed, etc. But the weaknesses is that it is hard to extract features from those RF images. Firstly, talking about the dataset, I would like to introduce our CRUW dataset containing a synchronized and well-calibrated camera and radar sensor system. It includes about 3 hours of 30 FPS data. The configurations and parameters of our sensor platform are shown in this table. There are 4 different scenarios: parking lot, campus road, city street, and highway. Some example images and object distribution are shown in these slides. In the ROD2021 challenge, we used a subset of CRUW dataset and divide into training and testing set with the ratio of 4:1. The ROD 2021 dataset includes both monocular videos and RF image sequences. The object annotations are derived from the CRF algorithm proposed in our previous work. The sensor calibration results are also provided, which includes the camera intrinsics and translation vector between the camera and radar. The challenge is hosted on the CODA lab, and we provide 10 metrics for evaluation, including AP and AR, which is average precision and average recall under different driving scenarios. The final evaluation metric for ranking is the average precision for total. To be more specifically, since we do not provide object dimension information like 2D bounding boxes, width and height in the image-based object detection, we introduced a point-based similarity called object location similarity, in short OLS, that jointly consider the distance between the detection and ground truth, the distance from target to sensor, and per class constant for error tolerance purposes. The OLS is always between 0 and 1, and we use that to replace the rule of intersection over union in image-based object detection. Here are some challenge statistics. The duration of this challenge is from January 15th to March 26, 2021. We divided the challenge into two phases. The first phase starting from January 18th to March 12th that select 30% from the overall testing set. And the second phase starting from March 12th to March 26th using the remaining 70% of the testing set. Overall, there are more than 260 participants in 37 teams from 10 countries. They came from both academic and industry affiliations. And in total, we received more than 700 submissions, including 300 from the first phase and 400 from the second phase. Here is the plot from the Coda Lab server. You can see the trend of the submissions through in these two different phases. The first phase leaderboard showing this picture, we received 19 public submissions, and we can see in the first phase, the participant can already achieve very good performance on our testing set. And here is the second phase leaderboard, where we receive like 23 public submissions. And here we have the ROD2021 Challenge final rankings. After the paper and code review, the following 6 valid teams are listed in the final leaderboard. Congratulations to all of them. And the first place, we have the paper named DA-NET, Dimension Apart Network for Radar Object Detection. The authors are Bo Ju, Wei Yang, Jin Rangjie, Xiao Qingye, Xu Chen, Xiao Tan, Hao Sun, Yi Fengshi, and Rui Ding. They are from Baidu. Congratulations. The second place method is called radar object detection using data merging, enhancement, and fusion. The authors are Junyu, Xinlong Hao, Xin Jiandao, Qiang Sun, Yu Yuliu, Peng Chang, Zhong Zhang, Fang Gao, and Feng Shuang. They are from the University of Science and Technology of China, Ping'an Technology, Pi Labs, Hefei Zhanda Intelligent Technology, and Guangxi University. Congratulations. And the third place method is called squeeze and excitation network-based radar object detection with weighted location fusion. The authors include Peng Liangsun, Xue Tongniu, Peng Feisun, and Ke Xu. They are from the Chinese University of Hong Kong, King's College London, Institute of Neuroinformatics, University of Dulwich and ETH, the National Key Laboratory of Parallel and Distributed Processing. Congratulations. So that's all for my part, and congratulations to all the winners of our ROD challenge. And I will give the time to the rest presentations from all the participants. Thanks again for your participation.